The Cauchy Integral Theorem is one of the most spectacular results in all of higher mathematics. What it says is that if you have a contour integral of, say, f of z over z minus z naught dz, where f is a holomorphic function and also z naught, as you can see, is a singularity. It causes the denominator to become 0. And if you throw around this a closed contour C, and some other requirements that have to be satisfied as discussed in class, smoothness and so on, then the integral of f of z over z minus z naught dz is simply given by 2 pi I times f of z naught. So actually it involves integration without doing any integration. How cool is that? Now, this formula can be modified. If you differentiate this a number of times, if you differentiate the both sides a number of times, you can modify this formula to include terms in the denominator that have certain powers. So you see, if you differentiate, for example, 1 over z minus z naught, you'll get minus 1 over z minus z naught squared. And if you do it again, you get z minus z naught cubed, z minus z naught to the fourth, if you keep doing this. In other words, n factorial at the bottom. So the theorem then can be modified, and it can have the shape, the contour integral of f of z over z minus z naught to the power, say, n plus 1 dz, a smooth contour there, C. And this is simply 2 pi I, like we had before, but this time you have to divide by the n factorial that comes out from the powers, multiplied by f. Now we took the derivative many times, so you have to take the derivative here n times, if this is an n plus 1 in the denominator, at the point z naught. So this gives us a method to find the integral at any of these points, depending, it doesn't matter what the multiplicity of the denominator is. Now, let's take example number 41 in the book. So that says calculate the contour integral z squared minus 3z plus 4 over z squared dz. Now the singularity here is only at z equals to 0. And the curve or the closed contour given here is a unit circle. That's given. All we have to check now is that the singularity lies inside the unit circle or inside the closed contour, and it does. Therefore, now that we have established that, we can now obtain the integral in the following shape. So this integral here will be equal to 2 pi I over, now since we are dealing here with the z squared, in other words n plus 1 is 2, n is actually 1 factorial, and then multiply that by the derivative of f at the point z, which in this case here is z equal to 0. So here, of course, f of z is simply z squared minus 3z plus 4, that means the numerator, everything beside the z squared. And so f dash z will be equal to 2z minus 3. Plug that in here, you get 2 pi I multiplied by 2z minus 3 equals to 0. And z is 0, you get minus 3 times 2 pi, which is minus 6 pi I, which is the answer.